Thanks again for coming to the Fab Lab. This is like the first time we've tried anything like this. This is a 3-year project. So like I said this morning, my name is Shoji Sataki, and I'm one of the coordinators with Andy Brayman on this project. And so I teach at West Virginia University, and before we start, I'm going to introduce you to the person that's going to introduce these guys. But I want to make some general announcements, which is please make sure your cell phone is on vibrate or on buzzer, right? So the ringer is off, please. Yeah. And to let you know, if you are busy doing other things, we are working in here today and tomorrow. But if you can't get in here, we are also live streaming all of this on the 92nd Street Y virtual clay site. So it's being broadcast live throughout the entire world right now, right? So there may be thousands of other people in other pockets of the planet that may be actually watching you guys. So just a little warning that if you're picking your nose and stuff, you may be on YouTube, right? So anyways, I'd like to introduce Kelly O'Brien, who's going to be introducing these guys. And she was one of the NCECA Emerging Artists last year, and she works as one of our postgraduate fellows in the 3D print, in our 3D Fab Lab in our production program at West Virginia University. And I'll turn it over to her.
Thank you, Shoji. Thanks, everybody, so much for coming out. We're really excited about this whole situation and sort of asking a lot of questions about what this means in ceramics and what this means in all of our studio practices. So this is all pretty exciting for us, and we have just as many questions as you probably do. So I'd like to introduce from Tethon 3D in Omaha, Nebraska, Greg Pugh and Max Kaeter. And I had the great pleasure of working with them last August, and they were sort of the human faces connected to my first experience with 3D ceramic powder printing and really a lot of 3D modeling. I had done a little bit, but not a lot. So these guys are amazing. When I'm in the studio thinking, okay, I've troubleshooted everything that I can, what do? I'm going to text Greg. So they've been fantastic. Greg is the Director of Technical Operations at Tethon 3D, and most recently has been involved in their newest project, which is what they're going to talk about today, the Form Lab and their porcelain ceramic resin. And Max is the 3D modeling lead and digital artist, so he does a lot of the 3D modeling, which he'll also tell you a lot about, and he now sort of has taken over the powder printing side of things there. So without further ado, I think they're going to knock you out. It's going to be amazing. Thanks so much for coming, and everyone, thanks so much for coming out.
Thank you, Kelly. Well, thank you, Soji and Andy Brayman and NCECA for making this lecture available and having this digital clay fab lab put together. It's really great to see all the different people who are working in this material and trying to figure out what to do with it and how they can use it to enhance their artwork. So my name is Greg Pugh, like Kelly said, and this is Max Kaeter. We've been working together at Tethon for about 2 years. Tethon formed doing business in March. A couple years ago, we first debuted in Milwaukee in NCECA, and then we've been coming back every year to educate and let people know what's going on. So what we're going to cover in our lecture today is kind of design insights for how to 3D model specifically for our material, Tethonite and porcelain. And we want to show objects that have been made with our material and successful things and how some things aren't successful, but yet we've been able to modify the design or modify the way that we worked with the material in the kiln to make a successful ceramic object. So this, like I said, we work for Tethon 3D. We specialize in ceramic materials for 3D printing in that we manufacture materials. We also do a service for our powder-based 3D printers. So you can send us a digital file and we'll send it back to you, either bisqued or glazed as a finished object or something that you can work on. We're very hands-on with our clients. We work with you on an individual basis to help you produce a ceramic object that you're happy with and that can be used in your practice. So this is our studio at Omaha, Nebraska. We have, we're in part of the Lindsay Capitol building, so we have part of the space. You can see several of the powder printers on the side of the picture. And then the rest is our office area and where Max and I work from. And then there's a glazing lab, and we have also our resin development area. So Like I said, Teethon 3D develops and manufactures authentic ceramic materials for SLA, DLP, and PJP 3D printers. I'll explain what each one of those is in the coming slides. We also provide service for the powder printers, and then we do educational workshops on and off site. So if you would like to learn more about what we're talking here, you can come to our facility, we'll train you, we'll make a custom workshop for you so you can learn what you need. A lot of people will come to us not knowing much about ceramics, so we'll give them a crash course in ceramics, and then a lot of ceramic artists will come to us not knowing much about the digital medium, and we'll give you a crash course in digital. So we just really like to work with each individual client based on their needs so they can get what they want out of it. For more information, please go to teethon3d.com, or you can email Max or I at greg@teethon3d or max@teethon3d.com. So first I want to talk about Teethonite. Teethonite is an authentic ceramic material for PJP 3D printing. What does PJP mean? I want to talk about the different acronyms to help you understand and distinguish between each material. PJP is powder jet printing. And that's one layer powder, one layer binder, one layer powder, one layer binder. And here's a short video to explain how this works. So you can see the printer, and it's coming into the view of the printer. Where you see the dark object is actually the binder being laid down, and every time it gets whited out, another layer of powder is being stacked up on top of each other. After it's been printed for several hours, an object will emerge out of the printer, and you can see it here with just a little bit of powder around the object. You can let those dry just like traditional ceramics. They're a green, wet object that you can push it just like normal ceramics, but as it dries, it becomes harder just like bone dry clay. So you use compressed air to remove all the material, and then you put it into the kiln, and then you can fire it like traditional ceramics. So these are some of the objects that we've made from here. This was a lot of what we based our research beginning off of, is making cups and making a watertight object. So this was one of our first watertight cups, and we were pretty excited whenever we achieved this. So designs that work, things that have printed well and different things. So a lot of people come to us and ask, well, like, what does work? You know, because sometimes they'll have ideas that aren't going to work in this material. So these are a lot of things that were successful and that we thought worked well. This is a air passive evaporative cooler. So it absorbs water and it will sit in a window, and warm air will be on the outside of the house and can pass through this object, and the air will be cooled down through evaporative cooling to help act as a natural air conditioner for desert areas. So we worked with a client in California to make this project happen, and she displayed it, and it worked pretty well. She was happy with it. So this is just another profile view and then another detail of the object. So we work with a lot of ceramic artists as well. So this was a little bit more of an industrial design project, the last one. So this is Paul Matthew. He teaches at Emily Carr. We've been working with him for quite a while. We've been working with him on different ways to make larger forms. So we took his digital file. This is actually going to be a bowl, and we broke it up into many pieces, and we started to assemble it. So these are all the little tiles printed, and then we took those tiles and started forming them back together to make a bowl. So he has two halves, and so this is a really great way to make our objects in a low effort way. You can break it up into pieces and then fire it and then attach them together after firing. And we use Amico Bisfix to do this. So this is the glazed version. So these are a Demaxium bowl, which is a map, and it's based off of Buckminster Fuller design. And then Paul Matthew will go and decal over these. So we sent him the glazed form. This is a mug that I thought worked well. Like, not all mugs should be 3D printed. That's one of the things that we want to talk about. Like, it's harder to 3D print a mug than it is to throw it. So you really want to, if you're one to make functional ware, consider what you can add to it. And I thought this was a successful piece because it had a little bit more geometry and a little bit more interest for a functional mug. So here's its glaze with a traditional Celadon glaze. We do a lot of custom work for different clients. They'll come up with different ideas that they want to print. This is just the Simpsons shot glasses, so this was just like a one-off for a birthday present for his brother. Yeah, and then so this is a great example of an artist who is trying to just bring this digital technology into their own. Her name is Jess Benjamin. She makes these jackstones large scale out of clay, and so she went to her site of inspiration and took a 3D scanner and scanned the massive jackstones, and then uses those as a still life object so she can kind of gain reference from is also it's a little maquette of what she's doing large scale. And she was able to take her exact same way she finishes her jackstones in natural clay, and she brought that surface technique to the 3D printed object, and it worked well. So it was a great example of how a studio artist is using the same techniques that they have in their studio practice on the digital form, and it translated really well. You can also do some 3D scanning. So this is my self-portrait. I'm standing in an electric kiln, so that was just kind of an odd feeling, but you can have rudimentary 3D scanners. You can walk around yourself and, well, have somebody walk around you, and can't walk around yourself yet. But so you 3D scan yourself, and then you can print yourself out in ceramics. And I think this is a really cost-effective way of 3D printing because like the body is a little bit thinner, and it becomes a pretty interesting object for a good price point. And then so this is the glaze version. I'm a little bit of a klutz. If you work with me, you'll probably know that. So I spilt glaze on my shirt. That's kind of where it is. So we also have an educational facility, and we take on workshops. So this was a client that came in. This is a business. They're not artists. He was actually an MMA announcer. So he had no 3D printing background and no clay background. But he came with a business, and they learned how to 3D print, how to glaze, how to use digital software, everything. And now they're using our material in their facility to make houses for realty companies. So when you buy a house, you get a house as your moving in gift from the realty company. And so these are some of the very first ones that they started, and we have some really, really nice examples at our booth upstairs. So this is a sake set. This is a functional dinnerware set. I thought this was one of the most successful dinnerware sets that we've done just because it's small, it had multiple pieces, and it kind of fit its profile. So like sushi rolls are small, so this is kind of an individual sushi sake set plus chopstick holder. And it just came out nice. It was easy print. It was a cost-effective design, and they were able to get through the design really quickly. We get a lot of files off of the internet where people just want to print it. So this is a Bulbasaur you can find on Thingiverse. And it's a planter, so we often print planters in our ceramic material because of just how it works. This is another file off the internet. So this is from the Smithsonian Museum, and this is Abe Lincoln's life mask. So it's kind of cool that you're able to print archaeological objects for your own observation or learning, and so you can kind of just get, see what it actually was like, and you can actually hold it. We work for archaeologists as well. So this is an archaeological scan from Cyprus. So an archaeologist goes to Cyprus every year and was doing archaeological work, but one year they were able to bring a 3D scanner and collect quite a few scans. So the archaeologists had us print out the objects that were similar to our scale that we can handle in the printer of the actual object, and we matched the color surface to what the original object was. So now she was never able to take that object out of Cyprus, but now she has a copy where she's had it printed a couple times and given to clients and friends so everybody can share this object and learn from it. And it's pretty exciting because now you can bring pieces elsewhere without having to deal with like nations and whatnot. So this is some of my artwork, self-promotion, but I'm more interested in low effort, high yield whenever I'm dealing with this technology. So it's like, what can I get modeled quickly? What can I get printed quickly? And what can I do for barely any money? Like what is cheaper to have printed and get results back quickly? Because if you send us a file that's going to take 18 hours to print and it is not successful, then you're going to have to go back to the drawing board and start over, and that's a lot of process. But if you can gain information about how to print in a quick way with low effort, then you can succeed a lot faster. And that's a lot of what I try to do with my designs. They're often quick modeling, quick printing, and I get a lot of information very quickly. This is John Balistreri. He helped start the formulation of the powder printing, and so he likes to have, he doesn't know much about 3D modeling, but he's still very active in it. So he has people model for him, and we call it armchair modeling, where he sits back and then has Max move the mouse and move the computer, and he's dictating what he is doing to make the forms that he wants. So this is a sculpture that was completely conceived in the computer, designed in the computer, and then printed, and then he has been finishing them. So that's just the slipped version, and that's what we send John, and then he'll go and finish it and glaze it and make it his. So we get random parts all the time. We're never quite sure what they are. This was a blob, but I think it's just like an interesting form and the way that the glaze reflects off of it, and it's pretty simple, but yet it turned out really nice, and I think this was a part of another piece. We make lots of functional objects, so it's the menorah. Things like this are just really simple, really easy, and it serves the purpose of ceramics. Kelly's piece, O'Brien, there you go. So when she came and did the workshop with us, she took the forms that she was working with in her normal art, and we were able to model and teach her on how to make this and kind of distort it in the digital form so she can start to understand what the technology can do. And so we printed this and put it all together and shipped it back to her, and so she can finish it herself. And that's a lot of what we do with artists, is we ship them the slipped piece so then they can finish it themselves. So Chris Gustin, we had the opportunity to work with Chris Gustin for a couple projects now. He came and took one of our workshops, and he was there for a week, and he was like John, he had no interest in learning how to 3D model, but he wanted us to 3D model for him, and we were able to make and produce 72 T-bowls in about 5 days, and he can forever just sample from those 72 T-bowls, and we numbered them and made like a catalog, so he can just tell me, I want number 45 printed at this scale. And we'll addition it according to him. So we just put like 1 of 5 or 2 of 5, and we keep track of the additions with him. So these are all based off of a sound wave. So people will often either touch his pots first or speak into it and get a resonating sound. So he was able to record that resonating sound, and then we took that sound, the 2D picture of just a sound wave, and we extrapolated it into a 3D sound wave, and then we took that and started to manipulate it into the shape of his T-bowls. And he chose the T-bowl because it would fit the same scale as the printer. You know, he was very focused on doing that. He wasn't interested in making a vase that was just smaller. He wanted the scale to mean something. And I think that's also important. It's like how to work with the scale and make it appropriate to the object you're working with. So if you come to our booth, we have some of the finished ones, and we actually have a finished one over on our table, and they're absolutely gorgeous. He wood-fired them, and it worked out really well. So this is another example of tile work. We do a lot of different tile work, and this is a 2D image. Max is going to explain this one a lot more. It's a 2D image made into a 3D tile relief by manipulating the blacks and whites of the black and white image. This is just another example of the detail of the tile and just the kind of surface that it makes. So this is all powder, the printer still. This is just an electrical part that we do multiple electrical parts and mechanical parts for different engineers, and this one was for a fan. And so this was another artist who took one of our workshops, had no 3D modeling experience, but we 3D scanned him, and he's a sculptor, so he used a sculpting program that was somewhat familiar to him through his natural techniques, and he just kind of manipulated his scan. He gave himself the mustache and the sideburns, and he just kind of gave himself a texture just to understand how to use the program. And I think this is a really quick way for people to start understanding what they can do in the 3D field and start generating ideas. So now I want to talk about Porcelite, our new material. Porcelite is a SLA DLP 3D printer. The SLA means selective laser, so it's a laser beam that shines on a resin that is cured by the laser, or a projector. So it's all UV light curing the resin and making a ceramic composite. You can take that ceramic material and then fire it in a kiln, and it will become a ceramic object. So here's a short video. This is the pictures of the printers. So the one I'm pointing to is the Formlabs printer, and then the other one in the image is an Ember printer. The Ember printer is a DLP, so that's a projector printer. So it's a projected image on resin that cures, all UV light, and then the Formlabs printer is a laser printer. And then here's a little video showing the Formlabs printer working. So you see the green light that's shining on the bottom, that's the laser making contact with the resin, and it's starting to solidify that object, and it's going to grow it out of the machine. So they're built upside down. It's not near as fast as the sped up image, of course. It's similar to the powder printers and similar to the FDM printers as far as time. But what's different about this is it's very, very high accuracy. and you don't really see the print lines, and it's a strong, durable object. The Formlabs printers, they can accept multiple different types of material, as well as ceramics, so you can switch between materials very easy. So if you want to print in plastic or a flexible material, you can with this printer. So this is the material directly out of the machine. This is our buffaloes that we've been printing. It's our company logo. You can see the layers are much tighter, and it's a very smooth finished product. So the lines, the vertical lines that you're seeing are support material, and those can be just snipped off using pliers, and those break off, and you can sand any kind of leftover mark to make a clean finished part. Here's just another image of pieces coming out of the machine. You can see multiple objects can be made on this machine at once, and so that can be pretty good for a production if you're making small parts. And this is just another example of a bisque object and a glazed cup. It's another just showing the detail of this printer. It can go extremely small. It's extremely detailed, and the parts fire much like traditional ceramics. And so we have this vase as well. So it's pretty fine detail. Just some more detailed objects. Like you can, I think the jewelry industry is going to be really great for this, just because you can quickly produce earrings or any kind of beads at a pretty rapid rate, and it's a low effort, high yield kind of object. These are just some more buffaloes. We just successfully completed our Kickstarter to release this material, so it just came out last month, and we're still getting it out there to the clients and getting some feedback, but we've been having good feedback so far. This is a 3D file that you can just download off the internet. I was just starting to learn what the printer can do. This is early on our testing, but it's pretty cool just to be able to print archaeological artifacts and really get to study them on a different level that you weren't able to before. Like, I think that's almost one of the coolest things about this stuff, is to really get to study and look at the intricate details of ancient work. So now Max is going to kind of go over how these things are made and some of the guidelines and the parameters of how these things were made. I just wanted you guys to see a lot of information about what is working, and then Max is going to kind of go over how we made all those work.
Thanks, Greg. All right, so I'm going to go over a few terms and guidelines for a product. Let's see pretty quick here. So the first thing that we want to go over is a bounding box. If you don't have any 3D knowledge, a bounding box is kind of considered like, if you put your object inside of a cardboard box, what are the dimensions of that cardboard box that you would fit it in? Our largest printer can handle 9 by 12 by 7 inches large of an object. But as Greg maybe described earlier, we're only limited by the kiln size, because we can print multiple objects and then slip them together with BizFix or whatever. Yeah. So.
Can we get Mike on, Max?
Am I not loud enough?
Can you hear him?
Yeah.
Okay.
Can you guys hear me? Yeah. All right, there we go. All right, the next thing we want to go over is wall thickness. So the wall thickness of the object is important to stability. We can't go super thin with our pieces because it'll break during the dedusting and handling process. But I mean, if you make them thick enough, it's fine. A good example of this is card-thin walls work for a house of cards, but not for an actual house. So another thing you can do to give a larger object the illusion of being thinner, though, is tapering the walls. It'll reduce cost and may give the appearance of a thinner walled object. Let's see. For embossed and engraved detail, probably about 2 millimeters is what we're finding for both is good number for how thick it needs to be or how deep it needs to go. Otherwise, it's going to be, the printer detail is not going to show it. Much smaller in our new printing material, but for our powder printers, that's where you want to go. Let's see. Glazing will also be another thing that covers up the embossed engraved detail that you want to be careful of, because otherwise it's just, you're putting all that effort in and you're going to get nothing out of it. So if you decide to print with us, cost-wise, or if you decide to print yourself, you want to make the object hollow that you're printing, if it's not already an open object. That uses less material up. You'll be able to get the material back and reuse it for printing. A lot of it is recyclable. Even some of the stuff that it has been printed on can be mixed in with and crushed up and worked again into it. So it's a very recyclable material to work over and over and over again with. Also, what you want to do is avoid extremely sharp intersections. So on a coffee mug, as we have an example here in the slide, You don't want the handle going directly into the mug shape. You want it to have a bevel going out, and that works for anything, any concave or even convex thing. You want it slightly beveled just to help out with the printing process so it doesn't crack. If you have an object with a flat bottom, you want it to have, as you can see, we use a coffee mug for a lot of examples, and later in the demo I'll be modeling a coffee mug. It's just a very universal thing that we can all share, especially for me as a digital artist, I can understand it. But for anything with a flat base, you want a concave bottom. It helps with the stability of the object and gives it a nicer appeal. Let's see. Now, problems that can occur and solutions that we can do. So Greg went over what worked. I'll have the bad part of going over what sometimes doesn't work, but how to get to a good place with it anyway. So here's a monument object that we did. Printed fine. It's in its powder phase when it comes right out of the printer. Here it is in its green state. It's dedusted. But unfortunately, the supports for it weren't working out with it. It tilted sideways during the firing phase. We went to the client and asked them, say, here, this is a big open area. The way it is, there's two pillars holding it up, but it's not really evenly distributed. Can you add an arch there? Which, unfortunately, we don't have a picture, but they added an arch, and we had a better success rate, and it distributed the weight more evenly, so it had less of a tendency to tilt back and forth. This is something we have to be concerned about when printing our objects. Along the same lines, as you can see on the top of this slide, there's that object that is just kind of wonky. And this wasn't anything to do with the client. This was how we printed it, what supports we used when printing it. And we ended up working with it again, firing it in a different way and printing it in a different way, and ended up with a more straight up and down piece that you can see here. So it's not always what the object is, it's how you print it. It's a whole different art form, how you put the object in the printer. Here's an object that we were able to salvage, but what would have helped is, again, some sort of arching in between the pillars support there that would have distributed the weight. Instead, that would have prevented that cracking from occurring. But as you can see here in the final product, you don't really see anything had broken. It was pretty easy to fix. Working with the client, we can go in beforehand and find a lot of things too, whether they decide to do it or not. These walls circled in blue were way too thin for this size of an object. Also, between the pillar and the outer walls, we knew something would occur, so we asked if he could add like a little mid-sized wall in there to get the object to print out successfully. And this object, second from the left, is that same one, and it was a perfect print. All these came out pretty well. Also on the one on the last there, you can see some cracks, but we ended up having him fill in more of that hollow area to give it more support. After a while, we got to a point where the client knew kind of what needed to be done. We worked with him enough. This printed perfectly, came out perfectly. We had no edits that we needed to do. All we had to do was have him chop it up to fit in our printers correctly, and then we threw it in the kiln and fired it. This project, we work with the client. This is an EKG reading vase of her grandmother's brain before she passed away. So we cut this up. You see a lot of sharp edges, something we had to deal with. So we worked around it and cut it where we thought it would break the most, and assembled it post and fired it together into this final piece. We're doing a second one for her as well for another show. We'll work with clients to thicken up certain areas. We'll see their design, and on the left you'll see that this is way too thin of an object to connect. That'll break very easily. It bevels into it, but it's just too small, so we had them edit it. Or sometimes we'll add more connection points to help with the printability. So here it was before we made any edits, and here's after where we got the successful prints. Sometimes it doesn't matter how much support you have. If it is too heavy on both sides of a thin area, the object will break. The client didn't want to do anything to thicken up the areas, so eventually we ended up still having it break and didn't finish this product. But it would have been successfully added a design around the waist of these characters and thickened up the wrist. Another example of something that needs to be fired or printed in a certain way, we fired this on it. We've printed it on its side with a support structure and fired it, and it mashed into itself through the firing process. All we had to do was print it upside down, put it on a fixture, and it held its shape. This is so we have our printing guidelines, but all our rules are meant to be broken. So if you have any overhanging areas like this, they'll bend in the kiln, but if we chop them off to begin with and add a little groove to reattach, we can print them all out separately and then apply them together with Bisfix and then fire them as one final object. So again, we have these rules, break them, as long as we figure out how to break them. It's just more effort on our end or, cost-wise. Here's what Greg was talking about. We had a 2D image from a guy and he wanted this popped out. So all the whites popped forward, all the blacks stayed back. So he wanted this figure. This is a little Buddha or Hindu figure here, and he wanted me to take that and pop it out more so it's more prevalent. So I went in Photoshop and gave it a more relief-like figure. So here it is in the 3D program. Here you can see it from the side where the depth is popping in and out. Here's another one. And this is the final glazed product. So that's about what we do. Those are all our guidelines. And if you can't figure out what to print, just take Soji's head and put it on a dinosaur. So I want to, yeah, he's a dinosaur. We can add a little more scales to it later. But I really appreciate everybody coming to this. If we have time, I'd like to take questions from everyone. Yeah?
Microphone, but I will. Here we go. If anybody has a question, I'll run around to you.
So after it's on, can you manipulate the object before you fire it?
With the
When it's like bone dry, yeah.
Yeah, with the powder printing, you do have some, you can manipulate it some, but it is a fragile object. You can slip and score pieces, not score, just slip pieces together, no scoring needed. You do have quite a bit of workability in that range. You can carve on it, you can do a lot of things, but it's not a wet, malleable clay object. It's like working with a bone dry, fragile object. So like what you can do in bone dry, you can do with our powder, but you can slip bone dry together. So that's a little bit different. And we also bisque to cone 6 with our material. Like I'm gonna call Max out. It's a joke we have, but like Max is like a very digital ceramic artist, and we fast fire for bisque. We fast fire to cone 6 for a bisque, and like Max thinks that's pretty normal for ceramics. So it's kind of like a different way. It's a different thinking. You can't blow up our material. You can fire it pretty much as fast as you want. I haven't been able to fire it fast enough. So it's pretty cool in that way. There's a lot of different things that you can do to it that you can't get away with in traditional ceramics. We're attaching things together at cone 6. It's just like a different way of working. You have a durable object, but you can put it together past cone 6, and that's pretty remarkable. You could probably do it past cone 10. I don't fire to cone 10 often.
When the binder or the resin burns out, does that tend to leave a more porous structure than a traditional vitrified clay?
100%, yes. So the ceramic powder is much more porous than the resin. So it's kind of like ceramic powder, resin, and then traditional ceramics is the most dense, and then you have mechanical ceramics. But it's definitely more porous, and it's contributed to a lot of that, but also the powder printer has no physical compression anywhere in the system. So it's just like a layer of loose powder laying on top of another layer of loose powder. We're working on developing compression into ceramic 3D printing, and we believe that's a pretty big part of it. So that is an issue, but because of the porosity, you can do things like fast fire to cone 6 and attach things together past cone 6. So it's like a good and bad. You just have to learn how to work with it and use it to your advantage.
So what would the what would the weight difference be between like traditional and like a powder form?
It's at bisque stage it's about 30% lighter, but as you infiltrate it with glaze in different slips, it becomes much more dense, and it really depends upon the materials of the glaze you're using, how much glaze, and all of that. The viscosity of the glaze and all of that. So it's kind of dependent on what you're doing with it.
Chris Guston's wood-fired pieces, are they fired to cone 10?
Yep.
And you fast bisque those to cone 6?
Yep.
Okay.
And then I slipped it.
Oh, you slip.
I slip after cone 6.
But this new product, you don't have to slip.
Yes, the new product we don't have to slip. So we put a slip on there to take care of the porosity because there is such a high porosity. We specially designed a slip to go with our material that has the right coefficient of expansion, so it will help stick to the body and it will allow for the glaze to seat on the surface instead of penetrating the body.
Do you have to have a specially formulated glaze in terms of the shrinkage rate for your
No, most glazes work. I'd say about 80 to 90% of all commercial glazes work. We really like Amico, not to try to promote them, but their glazes do work and they do fit nicely.
So I think you just answered half of my question, but I could talk about surface treatment for years,
Yeah, of
right?
course.
Traditional working.
Yes, of course.
And so how do you describe the surface treatment options for this process to people in a nutshell?
So the surface treatment is definitely a little bit, like it's just a little bit different, you know, like because of the whole firing to cone 6 first and then going down. But we'll fire it first to cone 6 and then we'll bisque it and then we'll fire our slip on at cone 04. And so that kind of acts like a bisque shell around it. And so that helps with the coefficient of expansion of the glazes to help fit. So that's kind of how we get away with it. And you can add stains, you can add underglazes, we've had luster, we've had china paints, things fire nice multiple times, but it really just comes down to the fit of the glaze naturally and how well it's going to work. There's some low fire glazes that we find that don't work, but most high fire glazes we have found worked.
And we'll just take a couple more questions, and then we'll give you a chance to see these printers in action.
Have you done freeze thaw testing?
Yes, it works. And dishwasher safe, all of that. The freeze thaw really depends on your glaze. We have special teeth-on glazes that we guarantee to work. But I'd say most Amico glazes are fine. Andrew had a question.
Hello. I'm just wondering, do you model your supports for the Form Labs, or is that in the software for the Form Labs?
Great question. It's all generated within the Form Labs software. So I'll be demoing that exact process in our demo up next, but there's some really great features. It's just like load in your model, click supports, choose your point size, your density. That's all controllable just through a little slider. It's really quite user-friendly. Generates the support, and then you just click print.
So you said when you bisque, you had supports for bisquing for some pieces?
Yes.
What type of supports?
For the Form Labs, we remove most of the supports because it's easier to file the support marks in the green state versus a cone 6 vitrified ceramic object. It's just hard to file it, we all know. So we'll add different type of support material to the firing. So we'll use alumina hydrate just because it's a non-sticking material. We'll use silica, we'll use zirconium beads, we use natural clay because natural clay will shrink at the same rate. We just use a lot of different things. We're always thinking about how clay can move, and that's just a lot of what normal ceramicists you go through every day. It's like, what's this going to do in the kiln? And you just want to think through that and what can you do to help move that piece in the direction that you want it to go, because it does shrink and there is no compression, so you kind of have to dictate how it's going to shrink. And we'll use just kiln posts and make a box in the kiln and then often put the object in the center and then just fill in with alumina hydrate around it, and that helps keep it up.